Hello, this video is entitled The Normal Distribution from the Larson book, section 5.1. Now, the normal distribution is a continuous probability distribution. We've already discussed discrete and specifically the binomial distribution, which is the most popular discrete distribution. Well, this is the most popular continuous probability distribution. There are others, and more advanced studies of probability distributions would encounter that, but for this course and our purposes, this is the one we want to study because it's by far the most popular and the most commonly used. Now the graph, so continuous, it won't be like a histogram or whatever, it'll be a continuous smooth graph. And let's look at the basic properties of this graph. The mean, median, mode are the same, and they're right here in the middle of the graph. The normal curve is bell-shaped and symmetric about the mean. Means you take one side and fold it over, it'll perfectly fit on the other side. The total area under the curve is equal to 1. That means if you took this graph and you could squeeze it into a 1 by 1 square, or whatever dimensions that would multiply it to be 1, 2 times 1/2 or whatever. But anyway, why would we care about area might be the first thing you're thinking, and that's a legitimate question. It's because we're going to see that area from this curve is how we're going to measure probability. So with the normal curve, area and probability are essentially synonymous. And this last property is not real important, but technically the graph never really touches the x-axis as it gets to the left and right, but it gets very, 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 very close. It almost touches it. So anyway, so when we say the total area is 1, that basically means if x is going from negative infinity to infinity. All right. And here's what I just said a minute ago. Probability is from area. Okay. Let's see. Let's look at the bottom part here while I boldface this real quick. Let's look at graph and look at, okay. Now the graph shows the normal curve. This one does with plus and minus 1, plus and minus 2, plus and minus 3 standard deviations. Now we're going to get a lot more sophisticated than that. We might want to know the area below 1.25 standard deviations, or which is what z is, or between negative 1.13 and 2.47, and we'll have technology that will help us with that. But you may recall the 1, 2, and 3 is what we learned when we had the empirical rule. That's where we did 1, 2, and 3. Now, if you notice this graph, and don't worry about this too much, like I said, we solve problems. We don't have to base them on this. We'll solve them a different way. But what I find interesting is actually this is more accurate. So between plus and minus 1 standard deviation, 68.2% of the value should be in that interval. Now, when we learn the empirical rule, this book and every other book I've used just uses 68%. I don't know why they don't bother just to go ahead and use 68.2%, but that's okay. Now, plus and minus 2 standard deviation, same kind of idea. We learned 95% with the empirical rule. More accurately would be 95.4. So I don't know why they didn't just go with that. Now this is the only one that matches the empirical rule. When it was plus and minus 3 standard deviations, it was 99.7%. All right, so let's take a look at, let's look at this property over here to the right. All right. So then you're not going to have to be really constructing, because when you look at normal curves, you can just make rough sketches if you want to look. Sometimes it helps people visually to shade the region that they're looking for. You may not need to. But this property is important because I could actually ask this on a test. And we have another example below. So they're always going to have the property with the mean being in the middle, like these two do. It'd be 52, and the total area is going to be 1. So obviously, if the graph is narrow over here, it's got to be taller. In other words, to incorporate that extra area. But what makes that happen? In other words, what makes it flatter versus being taller? Okay, that's a good question. And it's all based on the standard deviation. It's not the mean. The mean just sits there in the middle, but the standard deviation is what spreads it out. Because remember, that's what the idea of standard deviation is how scattered your data is apart from each other. So actually, the smaller the standard deviation makes the graph taller and narrower. Now this, we don't need to worry about this, but any equation, a graph's got to come from some equation, and the normal curve actually comes from this big old mess right here. And fortunately, we don't need to actually do that. And we will be using technology, and actually, if we weren't, finding the area requires calculus and a whole bunch of other stuff, but not our problem. But I just wanted you to see that. So it's got pi, it's got e, it's got the standard deviation, it's got the mean, it's got to have the x. So the graph is y based on all this other stuff, and there's an x in there because you got to have an well, unless it's y equals a number and that's just a flat line. So that wouldn't, so otherwise there better be an x in there. Anyway, now let's look at this. This is kind of going back to what I was explaining the previous page. Now look at these three graphs. You want to know which one has the largest mean. Okay, well the one that has the largest mean is going to be the one that's furthest to the right on the x-axis, because that's the center point's the mean. So B here would have a mean of 60. Both these other two have a mean of 45. So B has the greatest mean. And which one has the greatest standard deviation? The greatest standard deviation will be the flattest of the three graphs. Flattest, and that'll be C, and the one that has the smallest standard deviation would be the tallest and narrowest, and that would be A. So the taller and narrower makes it the smaller standard deviation. So that's all. So that's possible you could have a question like this, but it's not too difficult. Okay, let's come down here, and we have. And don't worry about this right here. I'll just kind of skip over this, but I just put this in a calculator just for fun. And you had to really play around with the scales on the axis, but I put that ugly equation in there, and I did one with standard deviation 5 and one with 10. I use the same mean, so that way they would be centered. Yeah, they go by tens here on the bottom, 10, 20, and the one that the second graph, second graph with the larger standard deviation was the flatter of the two graphs. So that's just strictly for illustration purposes. You will not have to use any kind of technology to actually draw the graph. Okay. All right, let's see what we got here. When we calculate probabilities from a normal distribution, they will always be expressed as inequalities. In a continuous distribution, it really doesn't make much sense to calculate something like the probability of x equals a number. That would be represented as equals 0. I don't know if that'll come up in the homework or not. I generally don't put it on an exam. But because really, if it's continuous distribution, it's really, you can make an approximation of what it is as a single number, but it's really not that accurate. You're measuring an area basically, so there really wouldn't be any area at a single number. But I guess somebody, if they wanted to really do like what's the probability of x equals 2, they could do like an interval, between like 1.999 and 2.001 and do it that way. But we're not interested in that, so I'm not going to worry about it. Now, let me show you something here. Unlike a discrete distribution, whether it's just a regular discrete distribution or the binomial distribution, whether these inequalities have the equal there below it or do not have the equal, in a normal distribution, that does not make any difference whatsoever. But you'll have to remember that in the binomial and the other discretes, it makes a huge difference. Here, it does not. I'm thinking most of these will probably be expressed in questions where it doesn't have the equal, but if it does, it makes no difference. And here's sort of an explanation that I have why. You don't have to worry about the why if you don't want to. Just go with it because it is true, I can promise you. But if you're trying to find for example, a binomial distribution, if you're saying x is less than 3, you're looking immediately at 2. You would jump down the next, because the binomials, for example, 0, 1, 2, 3, 4, 5, all the way to n, that would jump to 2. But continuous means this random variable is continuously moving through the numbers. So technically less than 3, x could be something like 2.99999 forever, which is so close to 3 that the area would not be affected. The area would be exactly, well, okay, let's just say infinitely close to being the same thing as if you were just touching 3 itself. So that's the reason. It's just because you're measuring this continuously. You're not jumping down to the next value below 3. All right, so like I said, you do not have to worry about that. Just go with what I said over here, that the equal has no effect in a normal distribution. Like what I'm showing you right here, here's an example of a discrete, specifically a binomial. If you have like this, between 12 and 14 with no equals, that means strictly 13. But if you put equals here, between 12 and 14, that means 12 plus 13 plus 14. So it would include all 3 of those. Huge difference. Normal distribution, no difference. Because like here's an example where I just drew a picture. If the mean is 10, here's 12 and 14, just roughly. Obviously, the main thing is 12 and 14 are bigger than 10. So I just drew a shading there. So like I said, it wouldn't matter, if you're touching the 12 and 14 or not, it's going to be the same area. All right. Now, normal distribution, technically there's infinite possible normal distributions. So how could we, find probabilities for all the combinations? Well, we're going to see that with the technology. But one way is we can convert these to z-scores, and we've talked about z-scores before. Now, I'm not really using the charts anymore like I used to, chart lookup. We're using more technology. So this is z-score. We still need to know how to get the z-score, but it's not going to be as imperative as it was when I was using the normal distribution charts. But anyway, let me talk about this is important, knowing what the standard normal distribution is. There's one. These are all examples of potential normal distributions up here, but there's one that has a name. It's called standard normal, and it always means that and it's known as random variable z. We'll generally be using random variable x. Random variable z, mean 0, standard deviation 1. Any other, and you can convert any normal distribution value over to this value if you needed to do so by using this z-score formula that we've seen in the past. So to convert x equals 60 and x equals 32 from a normal distribution, so it's implying it's just a regular normal distribution with mean 48 and standard deviation 8 to a value for z meaning this standard normal distribution. So you would take 60 minus 48 divided by 8, you get 1.5. And this one, you take the 32 minus 48 divided by 8, and you get negative 2. And the z essentially is the number of standard deviations that the value is away from the mean. So 1.5 means your x value is 1.5 standard deviation measures above the mean. Negative 2 means it's 2 standard deviations below the mean. Okay. Now I mentioned that we will be using technology for this, but I kind of want to show you the standard normal table real quick. Like I said, you won't have to use it, but I feel like it should be my duty as an instructor to at least show you that idea. So let me Let me get rid of this. Okay. And this would be, I'll have this posted. I mean, you may never use it, which is fine, but I'll have it posted. I put here learning management system because it's right now is the time recording this. If you're a Lone Star student, it's D2L. If you're a UHD student, it's Blackboard. But I think those are going to be changing, so I just call it. That's what I mean by learning management system. I think both schools are going to be going to a different one here in the near future as I record this in May of 2023. But it's, it's where all the course information is posted. All right, so this standard normal table is a table that gives you have to get the z value from any standard. Either they could give you the z value, or you have to do like up here and convert it to the z. And its cumulative means this is always based on less than. And then but I can show you real quick how to manipulate it for greater than and less than and between two numbers. But the manipulation is also important whenever you're using even the technology, because you have to know how to work with it for the areas in different directions, whether it's Excel or the calculator. So the chart has 2 pages. Has a look on that left column, has a negative side for the z's, and you come down the next page, and you got a positive side for the z's. All right, and it's showing you a picture here. So the number you find off this table, it's showing you that it's this area here to the left. Well, let's take a look and back to our. Let's say, suppose you want to find the area to the left of a z-score of negative 2.19. So what you do is, to read down this first column, that gives you the first decimal place of the z. So this chart is based on the z being 2 decimal places. And I guess I'll mention this now, but I'll try to mention it again later. Some of the problems for tests and stuff when you're doing these normal distribution problems in future sections might be a little different answer you get versus what the answer's shown, slightly different, because some of those will be based on doing it this way I'm showing you now, whereas the technology would be more precise. For example, let's say if the z was 1.33333333 whatever forever, like 4/3. The technology will give you an area based on using more of those 3's, but the chart can only deal with 1.33 because it's just rounding to 2 decimal places. So it shouldn't affect you getting a right or wrong answer. I think the homework is geared to do either way. It'll accept it with either answer, I think. But you would just pick an answer very close, and I think we'll see that come up in future sections, but I don't want to mention that now. So it was negative 2.19, and the top row gives you the second decimal place. So you find the negative 2.1 row, which is right here. Then you go to the 0.09 column, which is far right. So you look at that, and you see that's where negative 2.1 row meets the 0.09 column, and it gives you an answer of 0.0143. Ta-da! Now it says find the area to the left of a z-score of positive 1.27. And come down to the positive part. Here's 1.2, 0.07, 1.27. So 1.2 row, 0.07 column gives you a z of 1.27, which then gives you an area to the left, as it shows in the picture here, area to the left, 8980. And I'm recording this video right in the middle of a thunderstorm going on outside, so you may hear some thunderous noises. Those noises aren't coming out of me. And here, okay, I just took a little snippet out of the table and just basically showed you what I just did. You know, you see the row and column are circled, so that's all that is. That's these two answers, so there we go. Now, let's talk about the calculator, and let's talk about the Excel. And you're going to see me do both of these in the homework sections. I'll just leave these in here for now. Or I might even do one here for another example. Now, what you're going to see for less than, you do normal CDF, and I'm going to show you how to get this negative 1e to the 99. In fact, well, I'll just go ahead and do this one. Might as well. It won't be in the prettier looking calculator like you see on the screen there, but that's on a different computer. Let's see. So if you go second, distribution, we won't ever be using the top one. The binomial, we used PDF and CDF. Here we only use CDF. So that's already there as default. Let me just clear it and I'll show how to enter it. So negative 1e to the 99 is basically representing negative infinity. It means you're coming from negative infinity to whatever your z value is, which is negative 2.19. So the way we do this is negative 1, second, right there above the comma. Now right there above the comma it has EE, but it'll put E when you put it in there. It just puts one E in there. Fine, that's what we want. And 99. Then your upper value, so it's like an inequality. You're going from the lower number to the upper number. And anytime you have an inequality, like an algebra or something that's less than, interval notation, it's going from negative infinity to your number. The upper is negative 2.19. And then we want this to be 0 and 1. Later on in the next section, we'll see examples where these won't be 0 and 1, but you want this to be 0 and 1. Now, technically, here the 0 and 1 do not have to be there. I mean, but you certainly can leave them there. The older calculators, like a TI-83, won't even prompt you for that. You have to just enter numbers in, and you won't need to put 0 and 1 in there. But anyway, there's the answer. And 0, 1, 4, 3 rounded. So you see I did it right below it with the without the 0 and the 1. So then, so the same thing would apply. You would just, the upper number would just change to 1.27. I didn't do this one where I eliminated the 0 and 1. I think this top one ought to convince you that it doesn't make the difference. But yes, if the 0 and 1 weren't there, this would still be the 8980 answer I got off the chart. And I'll wait and show you the norm sdist. It's just an Excel command. It's easier to use, I guess, in the calculator. You didn't have to do all that. I want to show you this because of the 1e to 99 business, negative 1e. You just put norm sdist, you put your z value, and true means cumulative for less than or equal to, as I mentioned up here. I didn't read all this out or whatever, but obviously you should read that. Okay. So we're always going to use true there. That means less than. But we're not always going to want less than. We're going to want other values. Like what if we want area to the right of the z, meaning in word problems that would mean greater than. If you want area greater than. Now there's two ways you can do it. because the chart directly is not going to give you the answer, and you have to, whether calculator, you just have to change the entries in there, and even Excel, they have to all be manipulated. You couldn't enter it exactly the same way, because obviously those ways we just entered it was strictly for less than. Now the chart means that we have, if you look at it, because if you look up the value, it's only going to give you the less than part, and you want the greater than part. So one way you can do it is these two pieces, the blank part plus the red part, have to add up to 1. So you could look up the z. That's not going to be the answer, but since they have to add up to 1, because the total area is 1 minus that value would give you the number you're looking for. Whether it's positive or negative, same principle. 1 minus. And the other way you can do this, if you're kind of using the chart, is you can use symmetry, meaning that because the graph is perfectly symmetrical, the area to the right of a positive z would be exactly the same as the left of a negative z. So you could look up, if the z is positive, you look up the negative number, and that would be the answer, either way. I see once again here, the area to the right of a negative z is same as the area less than a positive z. All right. So here's one I did by using the table value. Area to the right of negative 2.07. I did the 1 minus and looked up negative 2.07. And there's 0.192, but it's 1 minus that. So it's going to be 9808. Or, instead of doing the 1 minus, because it's to the right, you can flip it over and just look up 2.07. And there's the number right there. I can scroll back up, but that is the 0.07 column. So 2.07, directly you get 9808. Now, here it is. Now the calculator, you can rewrite it as, I just put the keystrokes in here really or whatever. Didn't need that, but may help. So you put the negative, because it's going greater than means you're like this. Here, okay, there's the interval written out. It means that number to positive infinity. So it's negative 2.07, comma, 1e to the 99. And so you put, so you make it 1e to the 99, and then 0 and 1, not necessary. There it is, 9808. Now the norm dist in Excel, so in calculator you can just change this and write it from lowest to highest. Excel you cannot. Excel you have to use 1 minus. So you just do 1 minus norm s dist negative 2.07 true. There is no option there. All right, so area between two different z values. Now between, whether it's chart, you look up the upper minus the lower z, and if you get them backwards and you get a negative answer, just change it to positive. So these are both negative z's. Yeah, the z's can be negative, but your answers, remember, these are probabilities. Even though they're area, they're also probabilities, so it has to be an answer between 0 and 1. So in the calculator, you don't use either of the 1e to the 99s. You just use the lower z, the upper z, and neither one of those apply. And of course, the chart means you look it up on the chart, look up the 2, then subtract. Now, norm s dist, you don't have the convenience of the calculator to the way they do it, say norm S dist only understands less than. So you have to do it sort of in a way like the chart way without using the chart, but you have to put norm S dist of the upper value, the negative 1.35, which is larger than negative 2.16, minus norm S dist of the lower. Has to be done that way in Excel. All right. Okay. So let's see. All right, let's move on down. Now here's one where it's asking, these won't may come up every once in a while, like in a home, maybe a test, but most of our word problems won't have this, but the homework may have it. But this is one where we want to find the total shaded area of two different ends. Now what you do there's actually a second way you can do this too, but I'd rather just explain it one way. So we're trying to find the total shaded area. So for this one, it's almost like you just treat it as two separate problems added together. That's the best way to do it. Well, I guess I will go ahead and tell you the other way to do it is you can do it as, since the total area is 1, you can do it as 1 minus the middle portion. In fact, I think I'll show that. I'll show this using technology here in just a second. So if you're using chart or using Excel or anything, you got to get the left piece first. If you're doing it this way, you get negative 0.0708, which you see that was from negative 1e to the 99 to negative 1.47, which is the norm dist right here. Now to get the upper end, you can do 0.68 first and then positive 1e to the 99, but in Excel it only works as norm dist. So you have to do it that way, and then you add these two pieces together. So if you looked up the chart, negative 1.47, now for this one, I use the flipping it over, so the area right of 0.68 would be the area left of negative 0.68. So if you look up negative 0.68, you get this number, which is what the calculator is getting. That's what Excel is getting, even though I didn't show the Excel number there. You add those two together, and that's your answer. But I think I will show you. Okay. Now let's look at this optional way to do this, as I was mentioning, is by subtracting the middle area, the empty area, and that will leave the outside two pieces. So it kind of gives you a couple of options on how to do this. So I'll go ahead and put the 1 minus here, 1 minus, do normal CDF. And because we're going between two numbers, we don't need either one of the 1e to the 99, so it's negative 1.47 to 0.68. Negative 1.47, 0.68. Zero, 1, that's perfectly fine right there. All right. Actually, since it's hard to see that when okay, let me snip this part out because you can't see it. So I put this in the notes so you could see what was entered, and then because you can't see everything here, so here we have it with the 1 minus. Like I said, we'll so even though you can't see the rest of that screen, you can see to the left, what was entered in there. Now let's try it in Excel. Now Excel, all right, let me Better stretch this out. It's going to be a long command. Oh, whatever that. I don't want to do that. I only wanted column B, just stretch. And get the formula text in there. Now we have to do 1 minus, but then I got to put this in parentheses because, you know, the calculator is more convenient when it's between two numbers. With this, you have to do sort of like if you were using the chart, the norm S dist at the upper minus the norm S dist at the lower. All right. And it's 0.68 the upper. And this is always true. Minus norm S dist. Negative 1.67. Close another parentheses. All right. Okay, I had a comma in there instead of a period on one of the numbers, so that's why I had an error, but now we're good. Copy that over to the notes. And I shrink this down, and kind of a long row for that one, so I'll put it right there. There we go. And I had mistyped negative 1.47 as 47 is negative 1.67, so I just paused the video and corrected that real quick. So now we're okay. My logic was right, but I just had a number typed in there improperly. So you see it matches the calculator answer, matches the chart answer. So there we go. Now I'm mentioning, since, you know, probability equals area, when you're doing these probability questions, less than means area to the left, you know, greater than means area to the right, the bottom one means area in the middle. Now I did those using charts. Now you could, if you want to practice those, using whichever form of the technology you want, but you're going to see me do this here shortly in the my math lab homework, so I'm not going to specifically work these. But it might not be a bad idea if you try them. But if you can do the ones in the homework, basically, you understand how to do it, I think you'll be all right. All right, let's take a look at some homework problems. And let's see what we have here. We're looking at a shaded area under the standard normal distribution with mean 0 and standard deviation 1. So I'll show you two ways of the calculator and Excel how to do this. So you can choose what method you like best. The calculator would be second distribution, normal CDF, and since it's less than, well, okay, it's already up there for us. It has that lower default, so that's what we want. But that's what you want whenever it's less than. You want the negative 1e to the 99. And then 0.34. And you can see it's already set to 0 and 1. And hit paste. Enter. So 4 decimal places, 0.6331. Now I'll go ahead and get the answer, then make sure if it's right, we'll make sure it matches in Excel. All right, so before I go, well, I'll go to the next. Oh, I don't want to do that. Let me go back. I want to go back. Well, okay, 6331. Okay, that was the answer. I'm not going to redo the problem again, but let's do it in Excel. Now I already have it set up for you, the less than greater than and between two numbers. I already have the command set up. We just have to put in the right numbers. Let's see. The upper number was 0.34. That's what I thought. But so I go over here. I can just change this up to 0.34. 0 or no 0, whatever. And there you see it. That was the 0.6331 that we got. So now let's look at the second one. Oh, it's giving me, let's move up one. And this is area to the right. Area to the right in the calculator. You have to do it as the number, 1.24. Because basically the negative 1e to the 99 represents negative infinity. So now we need positive infinity because we're going to the right. So now I put 1 second EE, but it only shows 1 E there. 99th, that's your representation for positive infinity. 0, 1, paste. 1075, and this time I'll do it in Excel before I hit enter. In Excel, there is no, it's always treated, the true means it's always treated as less than. So the way to figure out greater than, which I showed in the notes, is 1 minus the less than. So we can't do it, we just have to make it 1 minus. And so 1.24. With the calculator, we only have to change the order of the infinities. Now you can see both answers on the screen there. 1075. So let's try that out. Okay. All right, excellent. All right, that takes care of it. Now between two numbers in the calculator, we would go second, distribution, normal CDF, and you put the lower number first, the higher number second. Oh, sorry, I hit the wrong command. Must have arrowed down one too many. Oh, I got to click. Okay, I should have reset. Let me quit before I. All right, second, distribution. All right. The lower number is -1. The upper number is 1.3. And then 0 and 1. Seven, 4, 4, 5. Now, once again, Excel only understands less than. The calculator, you can make it understand different things, but Excel only understands less than. So what we have to do in Excel is do the norm sdist command of the bigger number minus the smaller number. So I guess what you could do sort of like I did. If you wanted to type all these commands, you could just put numbers in there and already have them. You could even save them as a file if you wanted to, and then you could then just put in whatever numbers you need for your problem. But this, for Excel, this is the top one's less than, second one's greater than, and this is between two numbers. So it requires a norm dist minus a norm dist. So this is 1.3, and -1's the lower. There you can see it right there in Excel, and then looks like it matches our answer. I like it. 7445. Excellent. Now the next three questions are just, they're the same thing. They're just asking them as probability. So I'm going to skip these three. So the first one's just the area left. Next one's area right. Next one is area between. So those three would be done exactly the same way as the first three. And now I'll do this next one here. One more, it'll be the last one. Got some parts to it here. So less than 1.08. It's got one thing in there. It's a little tricky, so that's why I wanted to do this one. Let's see. Well, I can do calculator, I guess. So I can go second. Now I need the, I'm doing less than, so I have to do -1 EE to the 99. And my upper number was, is it 1.08? Is that right? Yep. All right. 1.08. Enter. Let's try that. Let's put it in Excel. So all I got to do is come up to this top one, which that's the less than. Change that to 1.08. Hit enter. Looks like our answers match there, don't they? 0.8599. Let's see how that works. Wonderful. Greater than -0.29. So in the calculator, greater than means I put the number first, -0.29, and then I do the 1e to the 99 to represent positive infinity. 1, second, EE, 99, 0 and 1 are good. Paste. And okay, let's see what we get here with Excel. And we can use the middle one. Uh, 6141. Beautiful. Now these are less than -0.29 or greater than the mean. That's when it's or like that, two separate regions. I believe right at the end of my notes, I have that in there, an example where it's two separate. It's like adding a left piece plus a right piece. Now, the left piece is a less than. So we can do this all in one step. In the calculator we can. Well, I'm sorry, one step where we can add two commands together. So less than, and now it's going to be the -1e to the 99. Down to -0.29. Plus now actually I'll tell you, an easier way to do this second part. The lower value is 0. But that's okay. You don't have to know what I'm about to say here. But the total area under the curve is 1. So the area to the left of the mean would be 0.5, and the area to the right of the mean is 0.5. So even though you're not going to see this answer, and you can type it in yourself to check, you're not going to see this answer specifically. But if I did hit, because we're adding it to another thing. But this part here is only 0.5 by itself. But see, now I've already added it to that. So there should be 8859. Now in Excel, I didn't mean to bring that up. I'll do -0.29 here. And you'll see it specifically in Excel. Because instead of writing out one long command where I add them, this time I'll get the numbers individually. Oh. I see what I did. I put a comma by accident instead of a decimal. And then I'll just show you, I want you to see this here. Well, actually, it wouldn't matter where I did this, but less than or greater than 0.5 is going to be the exact same number, but 0. Yeah, you see that's 0.5. So if you take 0.5, that's the right half of the entire graph, 0.5. So 0.5, you see add to 3859 will be 8859. And then basically, okay, not much. They're just changing the number on the right from the mean, which was 0, and now to 1.08. All right, well, that's easy enough. But the calculator, I'll just do this. I'll go second, enter. That'll bring up my last command. And then I can just scroll right back over it, because the first part's the same. So if I go right here and go 1, I think I got to put insert in here. 0.08. And that should be right. And then now, if I go over to here and put in, now we did it again. Let's get the 1 in there. And then what I'll do down here is I'll just add A1 and A2. I could have written that out in one long command, where I did the first one plus the second one, but we already got it set up like this. You might as well just take, if you have to add two things together, just take the numbers and add them together like that. Well, you see that matches the calculator, doesn't it? So 5260. Excellent. All right, that concludes for this homework for the section 6.2, normal distribution, part 1.